Alright guys, so here's our refresher on how to solve systems of equations by substitution. So essentially what you're doing is you isolate the variable in one equation, and then you take what that is equivalent to and you substitute it in for that variable in the other equation. So we have one equation with all x's. What we're doing is we're saying this y is equal to this y, and since this is equal to that y, I can place it and substitute it here. Alright, so essentially all I'm doing is taking y equals and y equals and setting them equal to one another. Like this, 1/2 x plus 2 equals 3x minus 3. So you must recall doing that. Alright, now all we do is solve this equation for x. So remember when we are adding fractions, you need a common denominator. That's what we did there. Multiply by the reciprocal, and that reduces to just x equals 2 times 5 is 10 over 5 equals 2. So x equals 2. Now that we know x, we plug it back into the original equation, and we get y equals 1/2 times 2 plus 2, which equals 1 plus 2, which equals 3. So y is 3. And to double check our math, we're also going to plug 2 into here and make sure we get the right or the same solution. So we have y equals 3 times 2 minus 3, which is 6 minus 3, which equals 3. Alright, so we got it both times. That's kind of double checking ourselves. So our answer here is x equals 2, y equals 3, or you can write it as a coordinate pair, 2, 3. Alright, let's see just a couple more examples. Here, only one of our equations is isolated for y, the other is not. So in previous classes, you may have just taken this and substituted it in here and then solved away. What we're going to do is just practice always isolating y and setting the two equal to each other. That's how I'm going to do it in this unit. So what we're going to first do is isolate the y. So that gives us negative 3y equals 2x minus 7. Divide by negative 3. And we get y equals 2x minus 7 all divided by negative 3. So now we can set that equal to our other function. So we say that this equals 6x minus 11. So I'm ignoring this y equals right now. So I had y equals this. So now I'm just setting this equation equal to that equation. And solving away, multiply both sides by a negative 3. That gives me 2x minus 7 equals negative 18x plus 33. So we get 20x equals 40, which tells us that x must equal 2. Now that we have x, we're going to plug that back into our original equation. So we have y equals 6 times 2 minus 11, which equals 1. And just to double check, we'll make sure it works when we plug our values into the other one. So negative, just to check, negative 2 times our x, which is 2, minus 3 times our y, which is 1, should equal negative 7. I put a question mark here when I'm testing something to check to see, remind myself that I don't know if it's equal. I'm seeing if it is. So we've got negative 4. This multiplies to negative 3. Negative 4 minus 3 is equal to negative 7. It works. So we checked it. So our answer is y equals 1, x equals 2, or just the ordered pair 2, 1. Alright, one last one here. Alright, so now what we're going to do is we're going to solve for y in both equations. You could solve for x or y. I just choose to solve for y. It's sort of a habit here. So I'm going to add the 5x to both sides, so I eliminate it from the right, and that gives me y equals 5x minus 3. And then I'm going to solve for y here. So I'm going to, because I can do it either way, add an 8y and subtract the 24 from both sides. So these 8y's cancel, these 24's cancel. On the left I have 3x minus 24. On the right I have 8y. So I divide both sides by 8. and that gives me 3x minus 24 over 8 equals y. So now I set those equal to one another. So I have 5x minus 3 equals 3x minus 24 over 8. So I'm going to multiply both sides by an 8. That reduces there. And so that gives me, as I distribute here, I get a 40x minus 24 equals, these reduce, so I got 3x minus 24. So I'll subtract 3x. I got 37x. I'm going to also add the 24 here to both sides to cancel that out. So 3x is canceled, negative 24 plus 24 cancels, so what am I left with? Very good, 0. So if 37x equals 0, if you want to just carry it one step further, you have x equals 0. Alright, so that's alright, 0 is the number 2. So now I plug 0 into either equation. This one's easier, so I'm going to plug it into the first equation. So negative 5 times 0 plus y equals negative 3. Well, this is just 0, so y equals negative 3. That's my answer, and then just to double check that I did it correctly, I'm going to plug the x and the y into the other equation. Alright, because to be a solution to a system of equations, it means that the x and the y work when plugged into either equation. So it solves this one and this one simultaneously. That's where we get the title. So we have 3 times 0 minus 8 times y is negative 3 equals 24. So 3 times 0 is 0. Negative 8 times negative 3 is a 24 equals 24. So woohoo, it works. Alright, so that should be plenty of refresher to be able to go ahead and complete the next assignment.